All right, today we're going to decode one of the most talked about fields in, well, pretty much all of technology, data science. What even is it, and why does everyone from Harvard to Amazon seem to care so much about it? Let's dive in and find out.
So, back in 2012, the Harvard Business Review just drops this bombshell of a title, and man, did it stick. For more than a decade now, that one single phrase has kind of defined the hype and the promise of data science. It framed it as this magical key to unlocking hidden secrets and driving just incredible innovation.
Okay, but let's be real. Beyond the buzzwords, beyond that super flashy job title, what is data science really? Like, what do data scientists actually do all day? That's exactly what we're here to unpack.
So let's cut through all that jargon. We're going to go from seeing data science as just some popular buzzword to really understanding why it's become a core, can't live without it strategy for businesses all over the world.
You know, when you boil it all down, data science is really just the art and science of making data useful. It's this cool blend of math, statistics, and computer science that lets us find patterns and pull out actual knowledge from all kinds of data. I'm talking everything from neat, organized spreadsheets to the messy, unstructured stuff like text messages, videos, and social media feeds.
And the demand for people who can do this? It is absolutely massive. Projections are showing that this field could create a staggering 11.5 million new jobs by 2026. So yeah, this isn't just some fleeting trend. It's a fundamental shift in how the modern world works.
So, how does this all work in practice? Well, I think the best way to think about it is like a detective story. A data scientist is basically a detective, and their job is to show up to a messy crime scene that's full of clues, that's the data, and solve the case, to give a clear, actionable answer. But here's the thing they don't always tell you, the not-so-glamorous part. Before a detective can even start looking for patterns, they have to collect and organize all the evidence. Well, it turns out that data scientists can spend up to a whopping 85% of their time just cleaning, shaping, and getting data ready. It sounds painstaking, and it is, but it's absolutely crucial, because if your first clues are junk, your final conclusion will be too.
This whole process has a name: the data science lifecycle. First, you've got data ingestion. That's collecting all the raw evidence. Then you hit data processing, and yeah, that's that huge 85% chunk of time we just talked about, cleaning and organizing all the clues. After that, we get to the exciting part, data analysis, where you use all these cool tools to find those hidden patterns. And finally, and this is super important, communication. You have to present what you found in a way that people can actually understand and use to make decisions.
You know, a master detective almost never solves the case alone, right? They've got a whole team of experts. And it's the exact same way in data science. It is a total team sport. So let's meet the key players. On a typical team, first up, you've got the data engineer. Think of them as the architects who build and maintain all the systems that store and move the data. Then you have the data analyst. They're like the investigators on the ground, digging into the data to answer very specific questions. And then you've got the data scientist, our master detective, who uses advanced stuff to not just answer questions, but to actually predict what might happen in the future.
Okay, this is a super common point of confusion, so let's break it down. Think of it like this. A data analyst is basically looking in the rearview mirror. They look at past data to explain what happened and why. A data scientist, though, is looking out the front windshield. They use that same past data to build models that predict what's likely to happen next.
But, and this is a really big but, with all this power to analyze and predict comes some serious responsibility. The data we use and the algorithms we build with it, they aren't automatically neutral or fair. And sometimes they can go terribly, terribly wrong.
This right here is probably one of the most important questions the field is facing today. I mean, if the data we feed our models reflects the biases that already exist in our society, what do you think happens? The models will learn and sometimes even amplify those exact same biases. So what does that look like in the real world?
Let's look at a pretty famous example. Amazon tried to build this amazing AI tool to screen job applicants. But here's the catch. It was trained on 10 years of resumes, which were mostly from men. So the model literally taught itself that male candidates were better. It even learned to penalize resumes that had the word women's in them, like captain of the women's chess club. In the end, Amazon had to completely scrap the whole project.
And the stakes get so much higher when we're talking about the criminal justice system. There's this algorithm called COMPAS that's used to predict if a defendant is likely to reoffend. But when investigators looked under the hood, they found something really disturbing. I mean, just look at these numbers. Black defendants were falsely flagged as being high risk at a rate of 45%. That is nearly double the 23% rate for white defendants. The algorithm was just reinforcing a dangerous bias it learned from historical data.
Okay, so these examples are pretty scary, right? But the good news is the field knows this is a problem and is actively trying to fix it. The whole conversation is shifting from just building the most powerful models to building them responsibly and ethically.
One of the biggest ideas here is something called explainable AI, or XAI. See, a lot of these complex models work like a black box. We put data in, we get a decision out, but we have no idea how it made that decision. What XAI does is it tries to crack open that box so we can see which factors led to a decision. That way we can actually understand it and, hopefully, trust it. And then there's the whole issue of privacy, which is huge. How do you train an AI on super sensitive data, like our medical records, without everyone's private info getting exposed? Well, a really clever solution is called federated learning. It lets a model learn from data that's stored locally, like on your phone, without that data ever having to leave your device and go to some central server. It's a game changer for protecting privacy.
So building AI that we can trust isn't going to happen by accident. It really requires a solid plan, a roadmap. And that means doing things like conducting bias audits before a model ever goes live, demanding transparency so we know how it works, using privacy-first techniques like federated learning, and, this is a big one, creating diverse ethics boards to keep an eye on these powerful systems.
And that really brings us to the final big picture question. We now have these incredible tools to understand the world in ways we never could before. But the real challenge moving forward isn't just about what we can build with this tech. It's about what we should build and how we make absolutely sure we're using it to create a better and a fairer world for all of us. Thanks for tuning in.